In this session, we talk about the benefits of process control. We take the example of a reactor and distillation system, and we identify these 5 benefits with regards to this control problem. So now let's look at what are the control benefits we identified. The first thing is to ensure safety. So this is the first benefit of control, to ensure that an operation is safe. The second benefit is to protect the environment by preventing the release of materials and energy. So the protection of the environment, it can be considered within the domain of ensuring safety. However, we take the 2 aspects, ensuring safety for process and personnel, and the ensuring safety for the environment separately. So the second point is to protect the environment by preventing release of materials and energy. So you can think of the environment can be affected by the release of materials as well as by the energy. So that's the second benefit of control. The third benefit we identified is to protect equipment. So within the process, you can implement control to protect some of the equipment. The fourth benefit we identified is to ensure product quality and to ensure smooth operation. Now, product quality is always a concern, and from a control perspective, we look at this as one of the prime objective. And then finally, to do optimization. So controllers are implemented to allow optimization of the process. Now let's take a look at one after another how we can do it for this process under consideration. So suppose to ensuring safety, suppose you can think about this reactor part, that the reactor having a cooling system, typically it's done using cooling water, and if the reaction is exothermic, in that case you need to maintain the temperature, and the temperature is maintained by manipulating the coolant water flow. So you can think of, you want to measure the temperature and to manipulate the coolant flow. So that's for our first controller, to ensure safe operation of the process, because you need to maintain the temperature when the reaction is exothermic, and maintaining reactor temperature is one of the widely used control problem. Okay. So the objective is to maintain reactor temperature. So reactor temperature is the output. If we are denoted by T1, so the output is T1, and it's manipulated by this flow rate, coolant flow rate. So that's, if it's denoted by F1, so input is the F1. So that's the first benefit, achieving how to, in the context of this control problem, how to ensure safety. The second part, to protect environment by preventing release of materials and energy. So in that case, you can look at the distillation column. So if there is an explosion in the distillation column, that will cause a huge release of materials and energy. So to prevent that, we need to ensure that the pressure inside the column is maintained. So we have a pressure measuring device here. We can have a controller to maintain the pressure. Now to do that, you can manipulate the outlet flow from the column to maintain the pressure inside the column. So you should have something like a flow measurement here as well. So if I call this to be, say, F5. So for this case, the objective will be to maintain column pressure. So output is the P1, and the input, maintain the outlet flow. This become F5. So F5, I am meaning it to this, that's the measured flow through the outlet of the distillation column. Now think about how to ensure or protect an equipment. Now here we have a pump here. So if there is no flow to the pump, then it may cause damage to the pump. So to do that, you have to ensure that there is a sufficient flow to the pump. And to ensure that, you have to make sure that there is enough level of liquid in the tank here. So to protect the pump, we'll have to have an objective to maintain liquid level in column. So the output will be here in this case, if this is the L1, I denote by the liquid flow rate, the level of liquid. So that's L1. And if you want to do this by manipulating this flow, so that flow, if that's denoted by F4, so that becomes our 4. Here just take a look that I am naming the variable by the name of the device. So F4, whatever is measurement obtained by this flow measurement device, I name that as the variable itself. So that's about protecting the equipment. Now how to ensure product quality? Now you can think of our distillation. So if this is suppose a flash column, so the inlet temperature will be a factor for the product quality. So what you have to do, you have to maintain the temperature of the feed here. So if I denote that to be by T2, so you need to maintain that temperature. Now you can maintain that temperature by manipulating some other variable. What variable you choose, that defines the control configuration. Okay. Or you can think about maintaining the product quality to be if you have an analyzer here, you can have this measured and you can have a controller to manipulate this. So for this case, suppose there are two heat exchangers. One is using the process fluid, another using the steam. Okay. So you can manipulate the process flow to process fluid stream to maintain the product quality. So objective is to maintain whatever this one is the composition of the bottom product. So if you have an analyzer device there, if whatever the measurement, if I name using the same variable, so it will be A1 composition, and then the input variable, it can be, suppose you denote this to be using F6 and this one suppose F7. So the input is F6 for this case. Now the last one, what is about the optimization problem? For optimization, again, you can think of for the product composition, how you can really manipulate both the process fluid and the steam in a way that the use of steam becomes less. Okay. So the objective is to again maintain A1, but here input can be both F6 and F7, and the optimization objective will be different from the control objective. So the optimization objective will be to minimize F7, meaning you are trying to minimize the steam consumption in the plant. Okay. So in summary, you see that for this two pieces of equipment, you can implement all of these 5 control strategies to achieve those 5 benefits. So what you need to do, you have to identify which benefit you want to achieve, and then you have to identify what is the control configuration for that, identify the output and the input, and implement control, and you will achieve all this objective. Thank you.